recording, and we'll go ahead. Alrighty, meeting is started. Recording is going. I believe you guys should be able to hear me. Check. Yeah. I'll just verify that everything is as expected. Yep. Alrighty. Oh, let me just stretch real quick before we dive into the thick of it. And then I'm going to show the meeting chat in case someone posts questions. We're not going to be stopping a lot in this tutorial, guys. We're going to be basically going straight through because this is a big question. This was an actual question we have given on an exam. So, yeah. And it was worth about 50% of their marks. So, students complained when they got bad grades on this. Meanwhile, we taught them everything they needed for it, and they didn't show up for tutorials and classes and stuff like that, so they couldn't do it. So I'm going to go through this entire question. A lot has been already provided so we can play the game, but I'm going to go through what you need to code this question to get a 100%. Nothing this hard will appear on the final exam because you guys aren't comp size, but something still pretty hard will appear on the final exam because you guys should be able to do it. So, step one, I got to create a custom board exception because the question preamble mentions it. I severely do not have time to waste reading this. I apologize. I very much don't. This is a long question, a very rigorous question, and I'm going to be explaining as much as I can as I go on, which means that I don't actually have time to read the question. We're just going to have to go in, and you're going to have to trust me here when I say stuff. So, initializers take in two parameters, self and the size of the Go board. Go board can only be odd numbers. They have to be an odd number greater than 3, meaning that we're going to need a condition. If the board is even, it's valid, and the size is greater than 3, greater than or equal to 3, it's valid. So if this condition is not true, the board is immediately rendered invalid, and we need to raise a value error. This is very common in our object-oriented programming questions. We will give you conditions. If the conditions aren't true, you need to raise some sort of error. If the error is not raised, then we can define some things. Well, the first thing that was brought up in this string is self.board. Self.board is very much like a Sudoku board. It is a size-by-size board of zeros, meaning that I'm going to use a list comprehension to generate a two-dimensional board of the correct size. So, how do I want to do that? Well, I'm going to start with the inner list comprehension. First, what I'm going to do is I'm going to have a 0 for any variable. It doesn't matter. It doesn't need a name. And range size. What this is going to do is going to generate a list of zeros, and there's going to be however many this range returns in zeros. Then I'm going to do the same thing for blank in range size. Now it will do this list this many times. This generates a two-dimensional board of zeros. So if size is 3, what's going to happen is it's going to go 0, 0, 0, 0, 0, 0, 0, 0, 0. It generates a 2D list consisting of 3 items, 3 total times. This is a shorthand notation. If you guys do not like this notation, you could always do self.board equals empty for blah in range size do a line equals this for blah in range size, line dot append 0, self dot board dot append line. This set of code is exactly equivalent to this one line of code. All right. I've got to keep going, so if you guys have questions, just type them into the meeting chat. I will address them when I have time to breathe. So next up, self.whosMove, detailed above. By default, the starting move is black. Our solution accepted both lowercase black and uppercase black because students hardly ever read. We found this to be the case quite frequently. Like, people would assume, well, there's no difference between black, and black. And in all of the previous assignments, we've asked you to ignore case, so we should have expected that. So we added that. So I'm going to use lowercase black, but uppercase black is also perfectly valid. Valid num equals 1. This is going to be used specifically and only for my solution. It's hard to explain what it does, so I'm just gonna keep it kind of at the bottom of the background. Additionally, we need a current winner, which is set to false. That's detailed in the question. Self.winner equals false. Of course, I need the board size. Self.size equals size. Lol. I need to save that somewhere. And I'm going to save another parameter called self.past. Again, this is going to be used for my solution. However, this was not asked. So these two parameters were not asked by the question. However, they are going to be how I choose to solve it, because they can clean up code quite a bit. So let's move on to isValidMove. Like I said, if you guys have questions, post them in the meeting chat. I'm going to just keep plowing through this. Essentially speaking, this isn't too hard if you follow this. And technically speaking, you only need this much in order to have gotten full marks for this part of the question. I am adding self.past and self.validNum for a future solution. IsValidMove. IsValidMove takes in the player's move in the form of a string, meaning that I know that not only in addition to self, it should have some sort of input string. I don't know what that input string looks like yet, but I know that there is an input string. Next, it's going to detail what an input string looks like. There's an x coordinate and a y coordinate. I'm going to have to verify that the x coordinate is inside the self range. I'm going to have to then verify that it's not 0. There's going to be a couple checks. So let's take a look. First, if input string is equal to the letter P, this denotes a pass. Pass in a turn is a completely valid, basically skip. So I'm going to just return true, because if the input string is P, then the user has actively denoted to take a skip turn, a pass. They have elected to give up. Next, I'm going to get my x and y from my input string, assuming that it's not the letter P, by doing input string dot split by the comma. What that's going to do is it's going to take whatever this x and y string is, split it by the comma, and then have a list of x and a list of y. I'm going to then put those into variables. Next, I'm going to do x equals whatever the int of x is. Similarly, I'm going to do it with y, so I'm just going to use this notation again. X comma y equals int x and int y. Finally, we're going to do the if statement to make sure that these numbers are within the dimensions of the board. X has to be a number strictly greater than 0 and strictly less than self.size. Similarly, y also has to be a number strictly greater than 0. Or, sorry, no, it can be equal to 0, I should say, and within size. So let's go ahead and set up the conditions. First, if x is less than 0 or x is greater than self.size, then we know that this is a failing condition. Similarly, if y is less than 0 or y is greater than self.size, again, we're outside of the range of the board. For some reason, they have asked us to place a piece on a square that does not exist within our board. In this event, we are raising our custom board error. If this event is not true, however, what we're going to do is we're going to return whether self.board at xy is equivalent to 0. Basically, is the square that they are attempting to place a piece an empty square? Because you can't place a piece on an occupied square. Again, not a hard one, but there's a lot to be accounted for, and the question gives you, I think, most of it. Coordinates are a form of xy. X is horizontal, starting from left, counting from 0. Y is vertical, starting from the top. So yeah, the only thing it doesn't tell you is you can't place a piece on 0, but I think that's detailed in the rules of Go up here. I'm going to verify it is. Yeah. So it is detailed up there. So luckily, it's just you have to scroll up a bit and reread to verify you have all the instructions. Capture check. Man, we're already 10 minutes in and 2 functions down. Whew. I'm hoping I can get this done by the end of tutorial, mainly because this guy is technically not an official tutorial. Your tutorial time slots were up. We're doing optional tutorials at this point. Because yesterday was technically your final official tutorial. So, capture check. I know I haven't been stopping a lot for questions. Is this some kind similar to Simon 10 questions in pattern? Like instructions are given, we're asked to complete the whole class and function? Yes, basically. You are just going to be given a long block of text with instructions, and you are going to be graded on how well you can get the entire thing working. We'll be testing individual pieces of it as much as possible. However, at the end of the day, the entire class needs to work as a whole, so your grade will be greatly dependent on whether or not you can get the entire class working. And let me remind you guys, this question was almost 50% of the grade of last year's final exam. So it was not a small question. Anyways, capture check. Capture check is actually pretty hard. It's going to require quite a few leaps in knowledge. But what it's going to be doing is it's going to actually it's going to verify whether you could, as a player, capture a set of squares, legally speaking. So I'm going to just quickly go over the string, because I actually do need to go over the string to remind myself. Capture check takes a list of coordinates on the board, known as group. I've called it group, expressed as tuples of size 2. The coordinates in the list correspond to a group of same colored stones. So if I were black trying to capture white, the group is going to be a series of coordinates where white players could be found. For every stone in the group, we're going to check the spots immediately beside those stones. Up, down, left, right. For each of those checks, apologies, my throat's a little hoarse. For each of those checks, if the adjacent space is occupied by a stone of the same color, check if it's in the group. If it is, keep going. If not, we're going to add it to our group so that way we can keep checking. Basically, If the white square is beside another white square, then we should not recurse, but like we should do the same checks on the adjacent white square. We keep going until we have stopped checking all of our adjacent squares. If the adjacent space is occupied by a stone of opposite color, we just have to continue to the next check. Basically, we can't check if we can capture because he is not our teammate in order to do any captures with. If the adjacent spot is completely empty, this group has at least one liberty, a detected space. The group is not captured, so the group is safely terminated. If all stones in the group are checked and there's no liberties, the group has been captured. Basically, if black has placed a stone and it manages to capture all of my white squares, all of my white squares have been denoted as captured. Go is a complex game. I'm not going to explain what all of this means. I'm just going to code it. Again, if you guys really are interested, I recommend read gameplay to get the rules and then actually play a game of Go. It is very difficult to explain, very difficult to understand, but that was the point of this question. This question was not so you would understand the game, because you do not need to understand something to code it. That being said, an understanding only makes it easier, hence why we gave so much preamble at the top. So let's go ahead and start. So I'm going to start with my first, from the group, identify the first square. This is going to be the starting square that I begin my adjacency checks. And what I'm going to do is I'm going to verify that that square is indeed someone that. Oh, how do I want to word this? I need to make sure that that square is actually a piece, right? So what I'm going to do is I'm going to first save the starting piece to a variable, mainly because I will probably be referring to it numerous times, and if not, it's still good practice. So x0, y0, and what I'm going to do is I'm going to verify that starting piece is not empty. So if it is equivalent to 0, that means that this isn't invalid. I'm going to just immediately return. No capture is occurring because I'm looking at a group of empty squares. Next, I'm going to add a array called new stones. This is going to be for my benefit in the future. So for every XY in group, I'm going to take a look at every stone in my group of stones. And what I'm going to do is I'm going to check up, check left, check right, and of course, you guys probably guessed it, and I'm actually going to do it here for consistency, check down. What I'm going to do is I'm going to fill my new stones array with every item adjacent to group. What it's going to do is it's going to be for my recursive check, because capture check needs to check all of the boards to the side, correct? So new stones is going to be filled with all of the other stones not in group that I should still be checking. So what is up? Well, if y is greater than 0, then I know that there is a potentially a down, or because remember, we start at the top of the board, so y equals 0 is the very top. So if I have y equals 0, there is no up square. There is no north. So if y is greater than 0, that means that there is a north. However, not quite done, because if self.board at x, y minus 1 is empty, then we don't, sorry, not as empty. This is why I have my starting piece. if the piece immediately on top of this piece is the same as the piece that we're looking for, what we're going to do is we're going to add it to our new stones for the recursive check. That's my bad. I should have. And recall, because it's recursive, we want to format it as a group, meaning it's just going to be a series of tuples of coordinates. So what I've stated that is if the piece directly on top of the piece I'm currently looking at also needs to be checked, I'm going to add it to a list so I can check it later. And what I'm going to do is I'm actually going to do this exact check for a series of pieces, the up, down, left, right. So what do I do here? If self.size minus 1, so basically if I'm at the bottom of the board now, don't do it, else do that in order to add the piece below. And then what I'm going to do is I'm actually going to copy this code because it works. I'm going to change this y to be an x, this to be x minus 1 for checking. I believe that should be left or west, however you want to say it. And then right is the exact same check. However, x plus 1. And this will check all of the adjacent pieces to see if they should be in my search for the next call, the recursive call, so to speak. So I'm going to get out of my for loop because I have now populated my new stones. Next, I'm going to verify that every stone in my new stones is in my group. Remember, I want to verify that, how do I word this? If the stones can be found in my group, then the stones don't need recursive because I'm already going to check them. If the stones can't be found in my group, then I'm going to have to recurse. So I'm going to set some sort of flag for if the stone has been found. I'm going to go for stone in new stones. If stone is not in my group, I'm going to set my flag to be false. This means that there is some stone in which needs a recursive check, and it will be helpful for later. Finally, I'm going to actually go through and check if anything needs to happen. So if my flag is true, then this means that every stone already could be found inside my existing group. I do not need any recursion. I don't need to redo the function with the stones, yada, yada, yada. I just have to do the calculation. So again, I'm going to do another for xy in group because there is no new stone. Every stone has been found in my group. And again, I'm going to check the up, down, left, right cardinal directions. But I'm going to check them for a different condition. So let me just tab these correctly. What's going to happen is if y is greater than 0, something is above. If x minus y is equal to 0, that means that they haven't been captured. So I'm going to do that. If the piece below is equal to 0, that means they haven't been captured. I'm going to return. If the piece to the left is 0, that means the group hasn't been captured. I'm going to return. And if the group immediately to the right is 0, that means they haven't been captured. In order to capture a group in Go, the group has to be fully surrounded. You can't capture a group if there is a escape, so to speak. We just got a warning about meeting time. Ignore that. I think I just incorrectly set up the group, so don't worry about that. So that is the series of what we need. If it manages to get through this for loop, that means the group has been captured. We need to delete it from existence. Black has destroyed it or white has destroyed it. So either way, what I'm going to do is self.board at xy for every member of the group equals 0. It has been destroyed. They've been captured. So this verifies that they can be captured. This actually captures them. However, what happens if our flag is not true? If our flag is not true, that means our group wasn't complete. We had to look at more items in the group. So what I'm going to do is for every stone in new stone, if stone is not in my group, I am going to add it to my group. Group.append stone. And what I am going to do is I am going to recurse on the capture check with this new updated group. Basically, once all of the stones have been added to the new group, I'm going to go right back to the top and I'm going to start all of this over again. This is not the most organized or fast or efficient solution, but it is a solution that works. There are so many things that can be done. For example, see how this loop and this loop are the exact same? When you set flag to be false, you could also do group.append right there because they're the same loop. And then you could just have the else statement just be that. But it doesn't matter. Code what works. Speed will not be tested on the exam. We do not test speed on the exam because it's bull. It's BS. Absolute bushkavik. It is unfair to give you guys that much pressure when we're just testing to see if you can code. Move. This is actually a pretty easy one, but also a pretty complex one. It's going to be like, you can see this is noticeably smaller than this. But there's still quite a few things that we have to take into account. So first, what does move take in? It takes in a single player string. So self and input string. Once again, if input string is a P, I know we checked for this in valid move, but what I'm going to do is self dot, and remember why I said that we're going to need a self dot passed. This is what it's for. Self dot endgame. If the person has passed already in the same turn, because you only get one pass. So if the person's passed already, they're going to check if the game is over, and basically the person's essentially resigned. However, if the person hasn't passed, we're going to then set self.passed equal to true. The person has now passed once, they have given up their ability. If the person does not pass, we're going to make sure that self.passed is equivalent to false. The person has officially played, they're back in the game. This is why I set up the self.passed variable, because self.passed is one of the unique rules of Go about how a person can do. Because, like, you know, in chess, how if you don't want to play a move on a turn, you have to resign. Go doesn't have that. Go lets you pass once. However, if you pass a second time, that is you resigning from the game. You have admitted loss. Next, we're going to get the X and Y from the input. Remember, we're under the assumption that accepts an input string in the same form as is valid move. We're going to be under the assumption that is valid move has already run in the previous turn, and whatever the person has typed is completely valid. So we're going to split by a comma, since that's what we did for is valid move. Next, we're going to do xy equals int x int y, exactly like is valid move. Now we need to do something pretty interesting. We're going to have to make an old board, a board copy. And what it's going to be is it's going to be sublist.copy for sublist in self.board. What we're doing is we're going to copy the state of the old board into a new board. This allows us to make any modifications to the new board without permanently impacting the game or preventing us from ever going back, because an undo feature is something that is very helpful in testing. I always recommend, if you're ever going to do anything, always save an old version of something in order to print the old version. This is a recommendation. I don't even know if it's actually required for the question. I do remember that originally we were actually going to force people to save both. This might be optional. This is still a good recommendation. I have this in my notes as something to bring up, so I'm bringing it up. Next, we are going to place the stone from the turn. The user has requested we place a stone, so we're going to place a stone. If the current self.whose move is white, what we are going to do is place a white stone on that square. If the current self.whose move is equivalent to black, we are going to place a black stone. Self.board xy equals 2, a black stone. Finally, we are going to attempt capturing. This is what happens after you place a stone. It is going to capture. The way I'm going to do that is through a loop for I in range self.size, for j in range self.size. Group equals the indexes I and j. We are going to then call self.capture check on that group. So it's going to go over every square in the entire board and see if anyone can capture, whether it's white or black. Because even on black's turn, black could make a decision so stupid that white ends up capturing. Finally, for bookkeeping's sake, if self.whose move is equivalent to black, then shocker, self.whose move is going to be set white. Additionally, I'm going to set my valid number to 2. Basically, this is going to be set valid number to whoever's turn it is. So I actually should have done this, because this is the whole point of self.validNum, is to skip doing this if statement. So I guess I didn't actually need validNum, now that I think about it, because an if statement can do it in a heartbeat. So yeah, fun fact, my solution is actually extraneous. It's always good to discover these things. So validNum, completely optional. That's my bad. I could remove it. Fun facts, I only needed self.past. That's pretty cool. And then finally, endgame. This one, not too much. Like, it's not bad at all. Assuming that the game is end, what we're going to do is we're going to set up a black counter, set it to 0. We're going to set up a white counter and also set to 0. That's why I'm doing this notation. This is a short form in Python. For every row in self.board, for column in for column in row. What we're going to do, if cell equals 1, that means the cell is black, and black counter is going to be do plus equal 1. If the cell is equivalent to 2, that means it is white. Our white counter is going to be plus equal 1. Finally, if black counter greater than white counter, that means black has severely outcounted white. Self.winner equals black, for black has 1. Elif white counter, is bigger than black counter. Self.winner equals white. And finally, if the two are exactly the same, which is our else condition, it's a draw. This is a very easy function. It's just counting how many black, how many white. Did black win? Did white win? Did neither win? So, I have finished with 10 minutes to spare. It is absurdly intriguing. Let's run a test case, shall we? So, here is the game that Nick has detailed. And we're going to run it and see what happens. Oh, whoops, change kernel. Run game is not defined. Did I seriously not run this? There we go. Go has been initialized. Move list detected. Executing the following moves. Black makes move 4-4. If we look, there's 4-4. White makes move 3-4. Black makes move 3-3. 5-5. 2-4. Ooh, there is a error. New stone, not new stone, new stones. Where did I make that typo? Capture check. Tisk tisk. Can you believe it? Your TA making such silly mistakes like that? You guys should all kill me. You should all bang up, get me fired. Cell is not defined. Did I seriously call it cell? Meanwhile, it should be self.board at row, self.board at call. Did I actually do that? Please tell me I didn't do that, guys. Please tell me I didn't do that. Where's endgame? Should be column. I'm checking every column in every row. I'm a failure. And bada bing, bada boom. Straight through to the end. The game is finished. Congratulations to White. You have won. So, as you can see, hard question. Not a lot of hard code. This is just a counter. This just places a piece. Hell, you don't even need this. It's just for printing two different boards. Like I could delete this and the solution is equally as valid. This is just really helpful for testing. This is by far the hardest question or hardest part, capture check. Capture check is the most disgusting part because it requires a form of thinking that doesn't quite come naturally at first. This is the part I struggled with the most. Identify a piece, check to or check every piece neighboring said piece and put it in a list. Then make sure every piece you have found is in the group. If it's not, we're going to put them in the group and redo the capture check. If it is, though, like we finally have stopped finding new pieces, do the capture check. It's an interesting function. It's a hard function. This right here, I do not think I am going to put something this hard inside the final exam. But you guys should be able to do it. It's, like I said, it's hard, but I believe in you. So, that is my solution coded in, 42 minutes. Can you guys believe that? The first time I ever saw this question took me an hour and 47 minutes. But I guess once you've seen the function once or twice, it gets significantly easier to code. So, if you guys have nowhere to be, if you guys want to leave, go right ahead. You have class in 7 minutes. Else, enjoy, stick around, ask questions. Coolio, one down. No problem.
Hi, can you hear me?
Yeah, hit me, man. What's up?
So, I didn't catch where the issue was, where you used cell instead of column. Could you please show
So
that again?
in endgame, I
Yes.
did for row in board, then
Mhm.
for column in row. And what I was doing is I was doing cell because I think in my notes I had this for cell in row, but I called it for
Right.
column in row.
Oh,
So
okay,
instead of
okay.
cell, I should have been using column.
Oh, I see, I see. Okay, that makes sense.
Just a typing error. I should have caught that.
Okay. Yeah, this question's like deceptively simple with what you have to do.
Yep. It is the most insulting thing because, like, the hardest part of this we actually did for you because originally you had to code this.
Oh, actually?
Yeah.
Okay.
Originally speaking, this was on the exam as something to code. And then I looked at Nick in a call and said no.
Yeah.
This is the worst. But yeah.
Well, I mean, I don't really have any more questions. Makes sense. Just gonna have to practice, I guess.
Yeah, this question is all about looking more intimidating than it is.
Mm-hmm.
I had this printed out. Yeah,
Well,
if you don't want to stick around, you can always head to class. Nothing's
okay.
keeping you here.
All right. Thank you.
No problem, man.
Bye.
Bye.